Hello, today I have very little time, so we're doing only 2 problems. Now, I'll start with the calculus one, to not clickbait people, since it's on the thumbnail. So we need to find the limit of this sequence and prove that it converges. So let's begin with the part A. Have to prove that if 0 is less than A, and A is less than 2, then A is less than square root of 2A, and square root of 2A is less than 2. Okay, let's begin with this part of the statement. We grab A is less than 2. Let's multiply both sides by 2. It's going to be 2A's less than 4. Let's take the square root on both sides because we know that A is greater than 0. So less than 2. That's it. Now the other part. So actually, let's grab the entire inequality here. We need to prove that it's going to be less than square root of 2A. Okay, so let's begin by multiplying everything by A. That's going to be A squared is less than 2A. Now let's take root on both sides. We have A is less than square root of 2A. Cool. That's basically proven. So now we need to prove that this sequence converges. So let's denote the sequence as Q of n. Let's say that Q1 equals square root of 2. And let's say that Qn is, actually let's denote this Qn plus 1 equals square root of 2 times Qn. Okay, cool. Now let's find the difference. Qn plus 1 minus Qn is gonna be square root of 2 times Qn minus Qn. Now, thing is, we have proven this statement for A that lies between 0 and 2, which would suggest that this is gonna be greater than 0, given that Qn lies on this interval. And thing is, another thing that we have proven is that square root of 2A is less than 2, and by the way, square root of any number is defined is also going to be greater than 0. So inductively, we can say that Q1 lies here. And the thing is, if Q of n lies on 0, 2, that implies that Q over n plus 1 also lies on this interval. So essentially, we know that this sequence is always increasing, but it's also bounded. It's bounded by 2. So, you know what it means? That means that the sequence converges. So let's say that the limit as n approaches infinity, Qn is going to be L capital. Now, thing is, that's going to be the same deal if we were to take the limit as n approaches infinity of Qn plus 1. Thing is, we can rewrite it as square root of 2 times Qn. According to laws related to limits, we can take the square root outside. And what we can do next is we can bring out the 2. And look what we have here. Square root of 2L equals L. Now let's square both sides. 2L equals L squared. L times L minus 2 equals 0. L is equal to 0. L is equal to 2. Now, thing is, it can't be 0 because the sequence is constantly increasing and square root of 2 is greater than 0. So it doesn't match us, and the only thing that we have left is L equals 2. That is what we're approaching. Which is funny because that's also the bound. Okay, cool. We have found the limit. Now, the problem from the subscriber that I have chosen, we're given that sine of x to the 4th power plus cosine of x to the 4th power equals 3 over 4. X lies between 0 and pi over 2. And we need to find the sum of cubes of sine x and cosine x. Now, the way I would go about it, let's write down the expansion of the power of the sum of cosine of x and sine of x. So that's going to be just this plus 3 times the product of sine of x and cosine of x times the sum of sine of x and cosine of x. So now the problem is more about finding the product and the sum. Now let's write it down in a nicer form so it's easier to work with. Cool, now our entire goal is finding the product and the sum. Let's begin with the product because it can easily be found through this part. Let's say that sine square root of x plus cosine square root of x, and that sum is going to be squared, is obviously going to be equal to 1. Now, thing is, if we were to expand this, it's going to be sine of x to the 4th power plus cosine of x to the 4th power is going to be 3 over 4 plus 2 times sine square of x times cosine square of x, which is almost what we need. So next, let's transfer this to the right side and multiply both sides by 2. The 4 times sine squared of x times cosine squared of x equals 1 over 2. Now, okay, I originally wanted to use a double angle formula, but honestly, that might be actually easier to not deal with it at all. So that's going to be 1 over 4, and so that's going to be 1 over 8. Let's take the square root of both sides. We don't need to include the absolute value for the reason of that we're working with the x from 0 to pi over 2. So that's going to be a square root of 2 over... Wait a second, I'm having a brain freeze there. Over 4, eh? Okay. Now we need to find the sum. For that, I would look into sine of x plus cosine of x squared, which is going to be equal to 1 plus 2 times this product is going to be square root of 2 over 2. So the sum is going to be just the square root of the right side. And I don't like this form. Let's write it down differently. Let's write it down as 4 plus 2 square root of 2 over 2. Now we just need to calculate this over here. Let's plug this in. Now here we're gonna have 4 plus 2 square root of 2 over 4 minus 3 times sin of x cosine of x, which is root 2 over 4. So minus 3 square root of 2 over 4. Now let's drag this under a root. That's gonna be 16 plus 2, that's gonna be 18. And minus 8 square root of 2. So now let's bring it into this root. It's gonna be 4 times 18, so it's gonna be 40 plus 42, 72. Now next we're gonna have plus 36 square root of 2 minus 32 square root of 2 is gonna be plus 4 square root of 2. And minus 32 over 8. In the root we're gonna have 40 plus 4 square root of 2. Let's bring out the 4. So that's gonna be square root of 10 plus square root of 2 over 4. We have calculated. Cool. That's it for today. Thank you for watching. Bye.